Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. So you are all welcome to this section of the tutorial. Today we'll be looking at organic chemistry and on the topic aromaticity. So what is aromaticity? This is the property of a cyclic and planar molecule having resonance bonds exhibiting more stability than the connective or geometric arrangement within the same kinds of atom. So this aromaticity is just a property that makes one compound more stable than the other. Although they may be having similar arrangement, but one will be more stable than the other due to what? Some resonance effects, some extra properties. And like for example, there are something that make people more stable than the other. Someone may look tired, dizzy, and weak, but the moment you give him money, he become what? Activated. And then he become more stable than the other one that does not have money. Especially when the need for money arise. The one that have the money is more stable than the one that has no money. So these riches, these jewelries, these riches in chemistry is referred to as what? Resonance. And it is attributed to what? Delocalization of pi electrons, which we are going to see in further lectures in details, inshallah. So but now let us look at this aromaticity, this property, these compounds that have this property. So now the rule of aromaticity, these compounds that have this property are called aromatic compounds. So how can we call somebody an aromatic compound? What makes us to say this person is rich? So what makes us to say a compound is aromatic? Number one, aromatic compounds are always cyclic structures. Yes, at our level now, aromatic compounds are all cyclic structure, but at further chemistry, you'd maybe at master's level, you will discover that there are some adjustment there. Then most have conjugate double bond. They always are alternate. It's not all conjugate. It's supposed to be alternate. Alternate. They have alternate double bond and single bond. That is, double bond will always alternate single bond. After a double bond, you see single bond. After single bond, you see double bond. After a double bond, you see a single bond. So this is what we refer to as alternating double bond and single bond. Must obey Huckel's rule. There is a rule called Huckel's rule. We are going to see it in a moment. It must obey that rule. And then the last one is the organic compound has to be flat. But as for now, we do not have business with this first one and the last one. Our main business at this level of the tutorial is these two, having alternate double bonds and also must obey Huckel's rule. The first thing you should check in the aromatic compound is, does it have alternating double bond and single bond? Number two, does it obey Huckel's rule? Now, let's see in details what we mean by this Huckel's rule. The Huckel rule, it says that aromatic compound should have 4n plus 2 is equal to number of pi electron. That is, the number of pi electrons should be equal to 4n plus 2, where n must be a whole number. N should be what? A whole number, and it should be a natural number. That is, it should be 1, 2, 3, and above. But in some textbooks, in some of our Nigerian textbooks, like organic chemistry meant by Dagari, Kutama organic chemistry, you see they attributed that n can be 0. But in international textbooks, so it's not accepted. 0 is not accepted. They start from 1. So it depends on you which one you decide to follow. But as for me, I start mine from 1 because 0 is not a whole number. So now, so let's take for example, they said predict if the following compounds are aromatic or not. We want to predict if these compounds written here are aromatic or not using our Huckel's rule. So remember, they said an aromatic compound must have alternating single bond, alternating double bond. Now look at this. We have double bond, single bond, double bond, single bond, double bond, single bond. All throughout the structure, we are having alternating single and double bond. It satisfies rule number 1. But that does not mean we have to call it aromatic. We have to pass through this Huckel rule. before we can call it what? Aromatic. Now the Hooke's rule says that what? 4n plus 2 is equal to number of pi electrons. Now how do we know the number of pi electrons? Each pi bond, each of these bonds that you are seeing like this carries 2 pi electrons. Each one bond carries what? 2 pi electrons. So now how many do we have here now? This one will be 2, 2, 2. So calculate them together. 2, 4, 6. So we have 6 pi electrons. That's why I said there are 6 pi electrons here. So we say 4n plus 2 is equal to what? 6. So 4n, subtract 2 from both sides. So we have 4n is equal to 6 minus 2. 6 minus 2 will give you 4. So 4n is equal to 4. But we are looking for n, not 4n. So 4 cancel 4. 4 cancel 4. N will be equals to 1. So remember we said when n is equal to 1, 2, 3 and above, it is what? The compound is aromatic. So in this case, we can say that yes, this compound is aromatic because it falls on what? 1. So now let's see this second compound. This second compound, let's see. Double bond, alternate single bond. Double bond, alternate single bond. Okay, accepted. It satisfies rule number 1. But you can't call it aromatic until you pass through what? The second rule. Because if you pass JAM, it does not mean that you have been what? Admitted. You have to what? Pass post-UTME. If you pass post-UTME, then you become a student. You will be admitted. But if you have tendency of being admitted, but if you did not pass post-UTME, you don't have tendency of being what? Admitted. So passing JAM is not a right for you to be admitted. So now, the same thing here now. This one has passed JAM. Let us see whether it will pass post-UTME. Now, how many pi electrons do we have here? We say each pi bond carries 2 pi electrons. So we have 2, 4. So we say 4n plus 2 is equal to what? 4. So now 4n, take this 2 to the other side. 4n will be equals to 4 minus 2. So 4 cancel 4. Divide both sides by 4 in order to get n. 4 cancel 4. N will be equals to 2 here 1, 2 here 2. It will be 1 over 2. So we do not, n is not a what? Whole number. Therefore, it is wrong. So they will say the compound is what? Non-aromatic. It is non-aromatic because it's not a whole number. So you can see it fails the second rule. So it's not an aromatic compound. Now let's see this one. Here, there is a lone pair. Look at these 2 lone pairs. These 2 lone pairs also, each lone pair stands for 1 pi electron. So this one is 1 pi electron. This one is another 1 pi electron. So this will be what? 2. This is another 2, so it will be 4. This is another 2, so it will be 6. So 2, 4, 5, 6. So there are 6 pi electrons here. So following our rule, 4n plus 2 is equal to 6. Transfer 2 to the other side. 4n is equals to what? 6 minus 2. So 6 minus 2 is 4. We are looking for n. Divide both sides by 4. 4 cancel 4. N is equals to 4 cancel 4. N is equal to 1. So this compound is aromatic. Now the last question, feel free to pause and try your best and see if you can solve. Then come back and watch it. So now look at it. This one, there is no any pi electron inside. No pi bonds inside. So therefore there will be no pi electrons. So that means we have 0 pi electrons in this compound. So now we can say 4n plus 2 is equal to 0. Subtract 2 from both sides. We have 4n is equal to what? Minus 2 over 4. Because 0 minus 2 will give us minus 2 over 4. So 4 cancel 4. N is equals to 2 here 1, 2 here 2, minus 1 over 2. So the compound is what? Non-aromatic. So this is how we detect aromatic compound. So next lecture we'll be talking about aromatic compound in details. We are going to be looking at benzene and benzene-like structures, the nomenclatures, the reaction, and so on. So but for today, this is where we are going to stop. Please take note, this is pi bond, and each pi bond has 2 pi electrons, and these ones are pi electrons themselves. So take note of this little confusion that can come. Once again, my name is Sam Muhammad. So this is where we are going to stop for today. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.